We are recording. Hello, my name's Idan Beck, and I will be teaching this fall semester's IGM309 Data Structures and Algorithms for Game Development, the sequel. Um, Really excited to be teaching this class. This is something that I really love. I'll largely be basing the material on a prior IGM 309 sections as provided to me by Alberto, who previously and is still teaching it right now. I'm going to be teaching this online, as you can see, or in the internet, and I'm going to be doing my best. I'm actually based on the West Coast in California, and we'll go through the structure and the organization of this class over this first lecture, um, and really excited to kick it off. So, hello, welcome, and sorry about the bad lighting. I'll get a new camera and new microphone soon. Oop, there we go. So you might want to know a little bit about me. So this is my first time teaching for RIT, and in general, I've never taught a class before, not in a classroom. I've taught a lot of people lots of stuff, just not in a classroom. So hopefully you guys will bear with me as I learn the ins and outs of all these different systems that RIT uses. But really excited. The material will largely be paralleled from other 309 sessions, both in the past and concurrently with classes being taught on campus during the semester. So I went to school at Cornell, which is actually how I got tied into the RIT IGM program through David Schwartz, who way back when was my professor when I was learning very similar subjects. I got a master's and a engineering degree, actually in electrical computer engineering, but believe it or not, I was doing crazy software stuff since I was 5 years old. After school, in the last 10 years, I've been out here in Silicon Valley trying to build wackadoodle stuff that sometimes other people care about. So let me kind of quickly get this out of the way. Here's some stuff that I've built. Here's some stuff that I've helped build or I'm helping with now. And this is currently what I'm interested in and kind of diving deeper into. Cool, so that's done. Let me talk a little bit about the organization of this class and how it's going to be delivered. We are going to have effectively two lectures per week, but given the sort of structure and organization of my time, I will be posting lectures at 9 a.m. Let's just see now that that's a p.m. That is not correct. That is an a.m., or it should be. Let me put my mouse over the... Sort of looks like an A. 9 a.m. every Tuesday, I'll be posting both lectures for the week. In fact, the sort of 9 a.m. Oh, the mouse went away. That's not cool. The 9 a.m. Deadline is sort of going to be for everything, and we'll talk about that more. I'll also be having sort of live office hours from 2 to 6 p.m. Eastern time. These will be done by way of Zoom, and I'll talk more about the kind of mechanics of office hours later in this lecture. But you guys will be able to come in, have a live conversation, share your screen, see your faces, all that great stuff, and I'll also be streaming that to Twitch. And I'm also streaming this to Twitch. I'm going to be, anytime I'm recording a lecture or anything, I'm going to be streaming it to Twitch. I'm going to try to do editing on lectures and things like that. I'm also teaching another class this semester, IGM302, but my time is limited. So hopefully Twitch will be a way for you to see how these things are going on live. So you'll see me, all the mistakes, all the stuff, and whatever. Hopefully it'll make you feel better about the fact that nobody's superhuman and everybody has to Google stuff. But hopefully that's useful. So as with everything in both this lecture and future lectures, please feel free to give me feedback and advice about what's working for you guys, what's not working for you guys. I'm not giving these lectures to hear myself speak. At the end of the day, if it's not helping you guys learn the stuff better, let me know and I will make changes. So yeah, please, office hours on Zoom. We'll stream that to Twitch and also the lectures. I've also set up a Discord. Some of you guys are on there now. I actually have it live, so if you guys talk into the Discord while I'm streaming, I will see it and I will say hello. Discord I like a little bit better than some of the other kind of mechanisms available for feedback and real-time communications. So yeah, definitely interested in your feedback on if that's good or bad. And also keep in mind there is the 202 section is on there as well. So please constrain 309 specific communications to 202. However, as I understand it, 309 is the kind of class after 202. A lot of people take it that way, maybe. I don't know. If you see people that are having issues in 202 or commenting to the general channel and you can help them, there's no better way to learn something than to help somebody else learn it. So I really recommend you guys help each other and help even other students that are not directly related to your class. The GitHub is currently empty. This is largely based on Alberto's class, so I will probably be pulling code in from there. I might make changes, we'll see, but eventually all the code that you may want to actually download and use will be there. Hey, hello, Matt Hoffman. How are you? Yeah, feel free also to use the Twitch chat. I have everything up. Like I have another monitor here, and it's like Command Central over here. It's ridiculous. Cool. So let me talk a little bit about email. Please don't use it if you can avoid it. I've already sent a number of you this kind of message. This isn't because I don't want to talk to you. It's because I don't like email. I get a lot of email not related to these classes. I batch it into multiple times a week. So whether or not you get a response is sort of based on the urgency of your email. I will probably see that you sent me an email at some point. But for most quick questions or runtime communication, I have an issue or whatever, I really recommend you use Discord or the My Courses discussion groups. But I prefer Discord. If you guys, again, everything is sort of up for discussion and up for debate. If you guys prefer the discussion groups on My Courses over Discord, that's better. Great. Say so. We'll move over there, or we'll do both. It's up to you. At the end of the day, all these tools and all these things are for you guys so that you can have the best experience and learn this stuff to the best of your ability. Let's talk a little bit about dates. The last day to add or drop this class is September 3rd. The last day to withdraw with a W is November 8th. I don't know why these were chosen, but those are the dates. We do have a TA for this class. His name is Nico. I got to meet him. He is awesome and a really great guy. So really recommend you also kind of seek out the tutors that IGM provides. I'm new. I'm not an RIT like professor for 30 years. I assume that this link is the link where you can find out where the tutors are going to be and when. And in particular with this kind of class, which is a little bit more, I'd say, theoretical, it's like C++, you're building stuff for real. I recommend a lot of talking to other people, getting feedback, getting support as much as you possibly can. My time is going to be limited. But really I recommend you guys collaborate with each other in terms of getting support and help and figuring out how things work. So yeah, great. Okay, grading. So the breakdown of this class is going to be a lot of homework, because I think, again, I am largely taking the existing curriculum and doing it online. I'm really excited about the project. The project does have a significant portion of your grade, but I think projects are really important for you to understand the fundamental stuff. And if you can do that, that's really the kind of focus of this class. There is no in-class participation. This is an online class. You can't miss an online class. And so that percentage has been sort of distributed into the grading rubric, and that is one of the deviations that the online class will have from the in-person class. Another deviation, I think previously when this class has been taught online, there was no project component. But I really feel strongly that a project is one of the most important things in a class like this. And since this is a full semester, not a summer class where you don't have as much time, this is going to be, the project is going to be a big part of your grade. and also we'll have an exam, like a midterm and an exam. I'm still trying to figure out exactly how these are going to be deployed. I understand that RIT provides proctoring services, and when I get details of that, I will post it to um, the respective places that it needs to be posted. Cool. I see 6 of you are on the Twitch right now. Oh, 5. Oh, I lost one. Drats. Okay. Exams are mandatory. So, like I just mentioned, uh, exams will be proctored. So you will have to go to them at a particular time, and if you miss it, you've missed it. There's no making up an exam. So while the exams are low percentage respectively, right? Like most of the classes I took in college, the final is like 60% of your grade or whatever. This class is a bit different, right? A lot of the things we're going to learn about are applied. Regardless, even though the exams are relatively low in terms of percentage, if you miss one, you lose 10%. So don't miss it. Don't sleep in. Get some rest. Show up. Do your best. They're mandatory. The exercises are done at your own pace, your own time, and are submitted by like next week. So the 9 a.m. Pacific time, which is 2 p.m. Eastern time, that is sort of like a cutoff, like a just a general thing. It's like I'll be trying to kind of batch all of the like all of this class into the front end of the week. You guys have the full week, and then you can post it, and we'll see how that works. And if we have to split up into multiple things, we'll talk about that. But hopefully, this gives you a lot of flexibility. I think one of the best things about taking a class online is that everything's really flexible. It's on your own time. So, yeah. If you have any questions about this, please, post it to the comments below. Anyways, homework. We'll release the homework onto my courses as soon as they're available. But the grading will not officially or formally begin until the Dropbox is closed. I'm new to the My Courses system, so expect some speed bumps here in the first few. Generally speaking, a due date means the 11:59 p.m. Eastern time of the day that it's due. But just like per what I just said earlier, mostly the due dates will always basically be Tuesday, like Monday 11, but really it's Tuesday morning at like 9. I'm not gonna look at it before then. Okay. With that said, how to procrastinate efficiently. So as I mentioned, there's a lot of flexibility in the timetables here. I want you to kind of be like appreciative of in a class like this. It's very easy to say, "Oh, I'm going to jump the moon. I'm going to implement like all this ridiculous stuff," and then you have like no time to do it. That means you're like an optimist. And you guys that think you're going to be able to do everything possible are probably going to procrastinate it until the last minute, and that's okay. If you're a different kind of person, like, okay, well, I'm so worried about how much time I have, I'm going to do it ahead of time. You're probably a pessimist, and that's okay. Like either style is great, and be kind to yourself. Just know which kind of person you are, and beating yourself up over it either way doesn't help. So this is my experience. Take it or leave it. The best way to procrastinate is the following: do one thing at a time. Multitasking is BS. Predict your time. So if you know that you're a pessimist, divide the amount of time you think it will take by 2. If you're an optimist, multiply that by 2. And always just base it in asking somebody else or getting a general feel. And then commit to the deadline. And so if we're talking about the final project, we're talking about a thing that's due in a few weeks, really set those deadlines and stick to them. Don't trust yourself too much in what you can or cannot do. Just know who you are, know your style, and surround yourself by insufficient people who are not your style that can kind of call you on your bullshit and help you get to where you want to go. So hopefully that's helpful to some degree. This class will include a project, so kind of on the back end of procrastination. You can choose up to another 3 people, so groups of up to 4 that you can work on in groups. Uh, so the groups need to be agreed upon by the project kickoff, which will be later in the semester. I believe I uploaded a course calendar that you can kind of check out. Um, Also, you can kind of feel free to begin working on this project like today, if you want it. Set your team and fill out the project description and all that stuff. I think that's also already online. But once you set it, the group cannot be changed. However, with that said, both from the beginning of like you can define your project today, you can change it anytime, even up to the day before you submit it. I don't really care, but your team stays the same. And once you submit that, the project description, which includes who the team members are, that's set in stone. So it's up to you. You can start the project now, or you can start the project when we kick it off officially at the end of the class, or closer to the end of the class. It's the last quarter approximately of the time. Great. If you have any questions about this, please ping me on Discord or whatever works for you. Okay, so the project's something I'm personally really excited about, but there is no like core strict way that we will be judging it. However, these things will obviously be a big part. How difficult is it? Like if all you're doing is taking a bunch of the code that's in the GitHub and applying it to something and drawing smiley faces everywhere, it wasn't really difficult, you didn't really push yourself, and it's going to be pretty obvious, then that's not going to get as good of a grade as something that is trying to like, oh, here's an algorithm off the internet, here's a white paper, we had tried to apply it, like, really push that. So, the ability for you to take a concept in this class and apply it, that's exciting, and that's kind of what's expected. But for you to take that application and kind of extend it into something that's beyond even the what we've talked about explicitly in the class, that's going to really push that forward. So that's what difficulty means. Quality is really important, both in terms of is it performant? Like if you're getting half a frame a second, that's not good if you're supposed to be building a real-time thing. Core should be code, the code quality. I guess core, you could call it core, but it should be code. The quality of the code is important to me because I'm going to be reading it. So please no like 1-letter variable names unless it's X, Y, Z, I, J, K. That's it. Anything else with a 1-letter variable name will get a pretty big frowny face from me. Please write good code, stick to good standards, good conventions, make your life easier, make my life easier. The quality of the code, if you're doing basically for loops for everything, that's not necessarily good. And kind of expect a little bit more of insight and kind of thought process behind how the code is structured. So that's what I mean by quality. And okay, the ability to execute on a vision that you outline, basically you're going to define the project and you're going to say, this is what we're going to do, and I'm going to be cool. And then I'm going to look at what you actually do versus what you say you're going to do. And that's a big portion of, I think, how these projects are assessed. Per what I said earlier in the previous slide, if you change what you're doing, I'm going to take into consideration the change and the amount of time and all that stuff. Like, don't worry. Don't do something you don't want to do just because you said you're going to do it. This project is really supposed to be a way for you to explore and work on new things. A big part of developing software in the real world is changing direction as you work on something, as you realize, oh, this is actually not possible, or this is not actually that interesting. So the ability to execute is not necessarily about, oh, I said I was going to do this and I did it even though it sucks. I don't care. What I care about is, hey, we said we're going to do this, and then we found out that it wasn't a great idea. So we changed to this, and then we found out that that's not a good idea. So we changed to that, and I'm going to follow that path, and that's what I mean about following a plan of execution. That's more important, in my experience, than the ability to just check off a box and said, oh yeah, we implemented this thing, but we actually never used it, which is a bummer. So the final bit I already kind of touched on, but if you explore new ideas that are not strictly presented in the course, that's like a big thumbs up for me. Like, I really want to encourage you guys to go out and, with a foundation of the kind of core concepts of this class, be able to attempt things that you might not think, you might not have thought of attempting prior to the course. So yeah, we'll probably have a half dozen set of these examples of things like that throughout the class. But if you have any ideas, if you want more ideas, feel free to ask. This final point is kind of complicated to explain, but in short, like, if you make a just passable thing and then spend the rest of the time making cool music and like cool models and stuff, great. Like, but that's kind of not the point. Like, don't miss the point. The point is, if you have extra time and you want to make it look shiny and aesthetically pleasing and all that fun stuff, then please do that. But that's not the point. The point is, really, we're looking for projects that really nail the core concepts of this class, demonstrate an ability to execute on those concepts, and even extend them beyond. So if you have not an artistic bone in your body, but you love technology for game stuff like I do, you're good. Don't worry about it. Like, I'm not going to care if your gargoyle looks like a dog. I have no idea. That's not the point. The point is not that. However, if you want to make it look aesthetically pleasing, and that's a big part, or if you want to create tools or create technology associated with aesthetically pleasing things, that's a different subject. And so, yeah, I'm not discouraging it, but please don't miss the point. The point is what we learn in this class, not making a cool video game. And that's it. So, yeah. Oh no, my time tracking tool. There we go. Okay, course topics. Let's talk a little bit about what we're going to learn. So this class is largely about the data structures and algorithms that are involved in the development of game technology, or real-time, graphics, real-time physics simulation applications. So it's not just strictly games, although obviously the name of this department is about games, but I will say that this technology applies to CAD software. It applies to simulation software like stress analysis. Obviously, the world of AR and VR and the applications they're in for industrial use cases, collaboration, communications. There's a lot of really interesting things that you can do with the concepts you're going to be learning in this course outside of simply game development. And I really want to kind of push that particular point. So we're going to learn a little bit about some more advanced graphics programming stuff. We're going to learn about physics and how to calculate real-time physics and collision resolution. And we're also going to learn about engines and how complicated just a general purpose software development environment for game technology is. It's a lot. There's a lot of stuff there. So to explain DSA, which I believe this is one of, there's a lot of C++. So we're going to be doing primarily C++ coding, which I'm a big fan of. C++ happens to be my favorite language, although everybody's telling me about this new thing called Rust that I don't know. I'm not sure yet. We'll see. C++ is cool. It's especially good for the kinds of architectures, algorithms, and ideas that we're going to be exploring. There's a reason why most modern game engines, at least at the core, are built in C++. Although, like I mentioned, some are starting to let's call it flirt with the Rust and other ideas. The APIs that we're going to be using, specifically the one we're going to be using is OpenGL. But we're also going to learn a little bit about DirectX and Vulkan and kind of why OpenGL is different than whatever. And so that should be fun as well. So I don't know much about DSA1. I'm assuming that you've taken it, but a review of the subjects that you should be relatively comfortable with. And I posted some review lectures from Alberta on my courses, so feel free to go through those. But generally speaking, all these subjects should make sense to you. You should just generally know what C and C++ is. You should know what big O notation means, the general concepts of version control, how to set up a Visual Studio project, data types, what those are, what scope means, and the difference between C sharp if you've used that before and C++, and also for declarations. You should know how to debug to some degree, although it's something that everybody can get better at. Testing and test-driven development, I don't know if that's something that they taught you in DSA 1, but I'm really excited to kind of dig into that. APIs and how APIs work and how to use documentation to make sense of APIs. Bitwise, like generally speaking, you don't actually do a lot of bitwise stuff, but you should understand it because it does come up, in particular with bit masks with relation to some of these lower level APIs. Unions, which are really useful in moving data around between the GPU and CPU. Endianness, which doesn't come up in much, but you should know what that means, and also what a C-style function is versus not. Also, you should understand the concepts of pointers and memory, because you'll find that we use those a lot. And also, what is a class, what is a structure, what's the difference, and also how do you use those to implement more complex design patterns and architectures. On that subject, yeah, you should know some design patterns. I think singleton observer have been covered. Also, what's a smart pointer and how is that different than a traditional pointer, and templates. The standard library is pretty useful. The rule of three, which is okay. Exceptions, file IO, all this stuff. You should you should know. I will mention that we will kind of cover search and A star as well. So yeah, a lot of cool things you learned in the last class. So what are we going to learn in this class? A few subjects of C++. We're going to dig a little bit deeper. We're going to use some new features that you may not have seen before, potentially. We're going to talk about OpenGL. We're going to learn about the frameworks and toolkits that you can use, and some of like what the functionality there is. That's actually going to be taught this week. We're also going to be using different libraries, things like Soil, things like Acid Importer Library, Free Image, who knows. Maybe we'll get crazy. We're going to talk a lot about transformations and how to do the translation, how to do rotations using quaternions, which is going to be exciting. We're going to understand about projections. We're going to talk about cameras and what that means, render lists, although and bounding volumes, all that stuff, collision detection resolution, both axis aligned, also oriented. We're going to do some SATs, and I'm talking about that SAT. I'm talking about the separating axis theorem. That's right. It's going to be great. And we're also going to talk a little bit about how to resolve these things and turn them into physics simulations. We're also going to talk a little bit about spatial partitioning. And this one I'm really excited about, because you'll find that some of the things that you would think are impossible if you were to do them with like a list become very possible when you start to do really clever things with spatial partitioning. And we'll also get into curves and surfaces. I think that's all the topics. Trying not to talk too deeply about any one of these. But yeah. So here's our great semester. I'm really excited. One of the differences between the online version of this class and the in-class version is I'm going to be giving the lectures effectively against the content. So some days it might be a 10-minute lecture for a particular subject, and sometimes might be an hour and a half. Who knows? These will be posted into my courses. So if you're watching on there, or you're watching now on Twitch, once I'm done with this, I'm going to move on to the next lecture. But for the most part, these will be arbitrary length. And again, I really ask you guys to give me feedback. If I'm talking too fast, say so. If I'm talking too slow, say so. If I'm not digging deep enough into something, say so. Or if you want me to kind of bring in other stuff into these lectures that are not in the kind of core curriculum, say so. Right. The idea here is to help you guys out as much as possible and give you what you need. So just be vocal, and I'm always here to make this better. So first lecture 309. Thank you guys. I'm going to stay on Twitch, and looking forward to a great semester with you all. Bye bye.